Welcome to the fifth session of this fourth module. This is actually a second chapter in this fourth module. We will be talking about the actuators. The actuators, I always say, whether it is a hydraulic systems or a pneumatic systems, these actuators are always called as a hands of a system. That means, though the heart and brain are there, we always does the work with our hands. So it is something like this, whether it is the hydraulic systems or a pneumatic system, ultimately the work or the mechanical energy is being utilized to do some work with the use of the actuators. Basically these actuators are also called as the air motors popularly. They are the one and the same. The pneumatic actuators are the air-powered motors which controls the valves and the dampers, remains the most reliable and durable and economical actuators available. Okay. It is easy to select the actuators which fail in the desired position upon loss of electric power. Though these actuators will certainly works out. In general words, if I want to define what is an actuator, actuators are nothing but a power. The actuators are the devices which produces linear or the rotary motion. Okay, or the actuators are the one which are in actual movement or tendency in the movement of due to the hydraulic action, or it may be a pneumatic action. Is that clear? A pneumatic actuators are the air powered to produce a rotary or a linear motion. In the broadest sense, an air cylinder is a pneumatic actuator. A cylinder, that is what cylinders. I always say, even in if you see any JCB, or it may be a dumping tractor or a dump trucks, a one cylinder which will be an extending one. Even in your JCB, if you want to extend their arms, you can see a silver color pipes like structures which are nothing but cylinders which are just extending it. Once if they want to come back, they will retract it. So they are the cylinders is an actuators. For this purpose of they are intent to produce, it may be a rotary motion. Even in your JCBs or the dump trucks, they tend to give a linear motion. In some things, in some systems, they produce the rotary motion, whether it may be a rotary motion or it may be linear motion. They are air powered and they give the motion. That is why we always term these actuators are the actual hands of these systems. And even for automating manufacturing, for clamping work, etc., in most of the applications they use these actuators. Their use is linear applications such as valve operating and positioning is also being used. Air cylinders in general are not covered for the formation of the other two types of actuators. Basically, a rotary actuators, if you want to talk about rotary actuators and the linear actuators. In the rotary actuators actually rely on a variety of mechanisms to produce the rotary motion. Say for example, when we talk about the rotary actuators, we talk about gear motors, or we talk about vane motors. Okay, so the different types of rotary actuators are there. Two common styles used are there, the pistons one and diaphragms. Diaphragm actuator and piston actuators. In one style, the piston moves on a rack and pinion arrangements, and the other style uses the Scotch yoke, a well-known kinematic link actually which produces 90 degrees to 120 degrees. That depends. I'll come to that once I talk about the vane actuators. Okay. Now this, apart from that, we also have a linear actuators. Let me concentrate on the linear actuators. A linear actuator is the one which produces a linear movement of the piston by the use of maybe a pneumatic force, or it may be a hydraulic force. So that is what we call it as a linear actuator. There are a few combinations where we can also see the combination of rotary as well as linear actuators can also be used. Okay, these actuators will also have a simplified diaphragms Okay, now it is pneumatic actuators all of the size cost much less than corresponding to the electric or electronic actuators. Pneumatic actuators are highly reliable, efficient and safe sources of motion which controls a pressurized air or gas to convert energy into the rotary or the linear motion. If it converts into rotary motion, it is called as a rotary actuator. If it converts into a linear motion, it is called as a linear actuators. Now, actuators are commonly used in control the valves that direct the movement of the fluid in the chemical or the process industries. That is one of the applications. Now, this is a one linear actuator. This is one linear actuator. The pneumatic actuators are the devices used for converting pressure energy of the compressed air into the mechanical energy to perform useful work. Now here you can see this. This is called as a single acting cylinders. Now linear actuators are classified into two types. One is a linear single acting cylinder and the other one is a double acting cylinder. In the single acting cylinder, what happens? If this is a pressure port, maybe coming from the compressor or from the receiver, if it is coming, this air pressure will be exerted over here. The higher pressure or the compressed air which is coming with a higher pressure, this pressure force will exerted on this piston end and makes it to move towards the right direction. That is what we call it as an extension. Now you can see if a dump truck is been extending and dropping the stones back to this to the ground, means it is been extending. That means the pressure is been coming from the pressure port and it will be extending. Now this is the piston seal. I'll talk about the sealing in the next session point. So this is the piston seal will be maintained here and this is a vent. Once this piston attains this position, that gives out a maximum extension, that is called as an extension stroke. This is a rod. For this rod it will be fixed a work. Is that clear? Now this is a spring. Now the spring return, this spring will be compressed. The spring will also have some stiffness matter which we call it as a K actually. Based on that this capacity will also be used. Now once it extends, after the work, if it has to return the stroke, what happens? The energy which is been stored in the spring is being used to release the load and make the piston to come back to this position. That means this is nothing but a return stroke. Is it clear? Now whatever it has, the air which has been come out here will be released over here to the vent. Now once again, if the work has to be done, then the pressure is being supplied through the pressure port or an inlet port, which we popularly denote it with the P. It will come to this portion and may apply this pressure and it just goes back. Now my dear friend, please be careful here. The pressure which has been exerted on the piston head will be more because it has to take the load or it has to move in an extension stroke. Once the work is been done and the pressure has to be released, what happens? A small or the energy which has been stored in the spring itself is sufficient enough to make the piston to go for a backward stroke or a return stroke. This is called as a single acting cylinder. Now this is called as a single acting because the work is does only when the piston is moving in one direction. That means the piston, when it is extending, it does the work. When it is returning, it is not doing any part of the work. So it is called as a single acting cylinder. Now when we go for a double acting cylinder, air is being supplied to both the sides of the piston, with one side at higher pressure which achieves the movement required to actuate the valve. Now here what happens? Now you can see the same pump or an inlet pressure port through which the compressed air is coming over here, and this high pressure fluid is applying the fluid movement on this piston head, making this to extend. Instead of the spring, we don't have a spring written, my dear friend, here. The piston will be subjected to an extension stroke. Now it will attain this position. Is that clear? Now when it has to retract, what is done it is, now the fluid will start flowing in this direction, and this the fluid which is coming from this, the second port, will exert the pressure on the back end or the rod end, which we call it as a rod end, or we also call it as a back end of the piston. Is that clear? So makes this piston to move towards the retraction or move towards the left side. Then the fluid which is been earlierly has been present here will be sent out here. Now once again the pump flow or the fluid, the air which has been coming over here, actually this is supposed to be the flow of air which is coming in this direction, makes this to move and the fluid will return into this direction. Now this is called as a double acting cylinder. It is only because the work is been done, or the energy it has been utilized, or the work is been done when the piston is moving in both the directions. When both the directions it is moving, the piston, the work is been done. Is that clear? The only difference what you can see it here, the pressure which has been exerted over here is more than the pressure which has been exerted over here, because only the reason is this is an extension stroke, whereas this is a retraction stroke. Is that clear? But work will be done in both the cases. Now on comparison, this single acting and double acting, now this is a single acting cylinder where it has to be returned by the spring action, whereas this has to be returned by the action of hydraulic or air supply. Now in the spring return or a single acting, what happens? It has a low to high pressure, whereas this is from the low to very high pressure it can go. From low to high pressure it can go, whereas this can go from a low to a very high pressure it can go. Its construction is very simple and it is reliable and best choices for the single acting actuator, whereas the double acting actuator, it is bit complicated. It is only because you have to place one spring over here, whereas here it is a two ports which are two ways. Is that clear? So designing it is bit complex and it is a secondary choice. Unless otherwise it is demanded, people will not go for the double acting actuators or cylinders. And then it is more expensive and secondary choice. For the choices, for when it comes to the expansion, it is more expensive, whereas this, it is the best choices for the double acting. Best for 8-inch and below, whereas this is for the 10-inch size and above, or also go for the higher pressure applications. For the double acting, it can go for a higher pressure applications, whereas for the single acting, you can go for only a low pressure or medium pressure applications. Now one thing, you can see it here, I was just talking about, when I say this double acting cylinder, the pressure which is exerting here with the complete surface which is available over here. When you have a cylinder like this, when you have a rod, if this is a piston, if this is a piston head, now there is a rod like this. Now this surface is being reduced, the surface area which is available over here is being reduced by this diameter. Now this is a rod diameter which has been fixed over here. Now that means the surface area here, it has been reduced by this, whereas this surface area has been completely available for the pressure of the air, whereas this, since it has been fixed like this, it is reduced by the rod diameter, that is been pi d square by 4 of the rod dia is been reduced over here. In order to eliminate that, the double rod end cylinders are used for the two loads simultaneously. Okay, now this cylinder and this cylinder, though this is a single acting cylinder and this is a double acting cylinder, in both the cases what happens, the work will be done only in moving the extension stroke. But in double acting cylinders what happens, even while retracting it, the fluid flow will be there and the work can be done. But the thing is, the pressure with which it moves in extension stroke will not be the same with which it go for the retraction stroke. It is only because the surface area which is available during the backward stroke or during the rod end will be less. The pressure available is less because the surface area available is less. In order to do that, or in order to take the load on both the direction, that means during both extension and retraction stroke, we want to take a equal amount of work, then they will go for double acting cylinders with a piston rod on both the sides. We have placed one more piston rod on the other end. We cannot increase this. So that, sir, can we remove this instead of keeping a rod on the other end and reducing the surface area for this piston end also? Can we remove both the rods? Yes, that is also possible, which we call it as a rodless pistons, and that is what we call it as a rodless pistons. But that is a different one. I just will come to that later on. Now this is where, in order to make the surface area similar for both the ends of the piston, I have placed one more rod. So what I will do it is, I will keep this is one actuator which will be working equally during the extension and equally during retraction also. Is that clear? So that thus they eliminate the differential area. The differential area which was earlierly was there for both the things will be removed, both for the rod side and the blank or the rod end side of the piston. The equal areas and cylinder volumes on both the sides of the piston, a given flow produces the same extension and retraction speeds. So both, once the fluid is entering into this port, the work will be done by this rod. Okay. Now whatever the fluid which was collected earlierly here will be sent back through this port. Similarly, whenever the fluid is been supplied over here, that makes this piston to move right directions, which we call it as an no, actually we cannot differentiate this extension and retraction stroke, because if it is moving in this direction, this is an extension stroke for this rod. If it is moving towards right, then the extension stroke for this. So one rod extension stroke will be a return stroke for the other. So vice versa it is. Okay. Now what happens? Due to this same combinations, the speed with which it moves is the same. The work will also be the similar one. Okay. Now the same thing is being done over here. Now if you see this, that is what, if you see this structural surface area in the single acting, this is a double acting and this is also a double acting now. Now if you see this, during the extension stroke, this surface area, this piston area during this extension, the entire piston area, which is denoted as AP, surface area of the piston, that is pi d square by 4, will be there. If you assume this d as a diameter of the piston, pi d square by 4 will be there, and it will be subjected to the fluid pressure, and it takes a complete pressure of that. That can be seen in this hashed position on the circle, where it shows the complete surface area which is available, which is experiencing the force by the pressurized liquid. Is that clear? So that it just moves. Then this is called as a velocity with which the extension takes place, which is given as V extension. Okay. Now the force with which it extends is nothing but F extension. Now if you see from the rod end or the blank end, okay, now during the retraction stroke, the fluid is coming from the backward port, where this will be maybe the same pressure with which it is coming. If it is coming with the 5 bars, even here also it is coming with the 5 bars, but the surface area which is available for this is AP, whereas for this it is AP minus AR. That means pi by 4 into d square minus d square minus r square. That is the pi d square by 4, the pressure of the area, surface area of the piston, minus pi r square by 4. That is r is nothing but the rod dia. Is that clear? Now here it is a return stroke where this is friction, retraction, and this is the velocity with which it is getting retracted. So this is obviously, since the surface area is less, obviously you are taking less. If this area is acting more, it will take the more. The velocity with which it moves will be very less. So that is the major difference between double acting cylinder with an additional rod and without an additional rod. You just imagine, even if I place a connecting rod on this end also, then what happens? The surface area becomes same. So speed with which it moves, the speed with which it takes will be the same. If not, what happens? It moves with faster rate and it moves slower like this. So that is the difference, that is the concept behind of this, between a single and double acting cylinders. Is that clear? Now, basically this single acting and double acting cylinders are, you might have seen it, wherein which lifting of the vehicles or dumping the trucks, what they do it is, when lifting, even when they are dumping the vehicles, dumping the load, while they are lifting, they need more energy for that. They need more energy for that lifting it. Once the load is been released, the load required is very much less. By the gravity or by the self weight itself, it just comes back. In most of the applications, they always prefer single acting cylinders because of its advantage. Now spring, it is some certain cases spring is also not required. By the gravity itself, it will come back. That is what we have a different types of single acting cylinders. One is a telescopic cylinder, second one is a gravity cylinders. Gravity cylinders are something like our pressure cooker. Once the pressure is been released, because of the visual weight itself, it just falls down. Is that clear? So due to that, what happens? It just self weight itself, it just comes below, comes to the bottom, and it just rests. So in most of the cases, whether it is maybe a dump truck, or it may be cranes, or it may be even in the JCBs, what happens? They use the single acting actuators more preferably than the double acting actuators. Double acting actuators has got different applications, where in the car manufacturing industries, where they have to move in the conveyors regularly. The load has to be moved towards the left as well as the right in the simultaneously. In such cases, they use even in your few of the even in the JCBs also, double acting, what they do it is, the same load with which it has to go, the same load it has to take it nearby, and it has to put it in the other places. So whenever the work has to be done equally on both the movements, then only they go for double acting cylinders or as double acting actuators. Ultimately, these actuators are the one which will be doing the work. We have got few MCQs doubt the questions. The basic function of the spring in a control valve is to characterize the flow, oppose the diaphragm so as to position the valve according to the signal pressure, close the valve if air failure occurs, open the valve if air failure occurs. No, it is actually the oppose the diaphragm so as to position the valve according to the signal pressure. That is true. The single acting cylinder generates more power than double acting cylinders. Is it true? No, it is false. In double acting cylinders, what happens? The power generated is more, even because the power generated even this in the extension and even in the retraction will be more. Whereas in the single acting cylinder, the power will be generated or will be used only when it is in the extension stroke. During the retraction stroke, there will be a spring return or a self weight return, or it may be a normal dead weight return will be there. Whereas in a double acting cylinder, what happens? The power will be utilized both for extension and both for the even in the retraction stroke. So that is why the power generated in the double acting cylinder is more. That means this statement is false. Actuators are called as the hands of the pneumatic system. Is it true? Yes, it is 100% true. A spring return cylinder generates more power. Spring return cylinders generates more power than double acting cylinders. No, it is one and the other same. The other thing itself, it is wrong. Okay, it is only because the stiffness of the spring. It is a common sense. I just shall show you over here. Here, if you see, whatever the energy that is being stored by this spring, it is only the part of the energy that is being utilized by applying this energy, correct? Say for example, if you are applying some energy over here, maybe around 10 bars of energy or the pressure with which the air is coming over here, the completely one which cannot be used during the extension stroke. A part of that energy is being stored over here. So when it is during the retraction stroke, what is happening? Whatever the small part of the energy, maybe 1 bar or 0.5 bars or 0.25 bars of energy that is being utilized for compression, this will be used to retract it. Whereas what happens in an extension double acting cylinder? If it is coming with the 10 bars of the pressure to an extension, it uses this complete 10 bars of energy. That is the reason why in the double acting cylinders it is more. Is that clear? We were talking, there was one MCQ question was there. Single acting cylinder and double acting cylinder, which has got more power generating? It is only because in the single acting, what is happening is 10 bars of energy, it is not being used to doing the work completely, because a part of energy it is being used for compressing this spring, that is the stiffness K, which will uses the energy storage, a part of energy that is being developed by, which has been acted on this piston. Is that clear? Similarly, when in the double acting cylinders 10 bars of fluid energy is being utilized for the extension, similarly when it has to be retracted, the same 10 bars of energy will be applied over here. Maybe the velocity may be different, my dear friends. Velocity may be different. Velocity with which it retracts may be different. The velocity with which it extends is different. But the thing is, the pressure or the energy which is available for the retraction will be 10 bars only. Whereas here in the single acting cylinders, it will be part of the 10 bar, that is maybe 0.25%, 0.25 bars, or it may be 0.5 bars. Whereas here the complete energy is available for that. That is the reason why the double acting cylinders produce more energy compared to the single acting cylinders. And in order to equip that, in order to make sure that the velocity remains same thing, we are going for the rods on both the ends. The rods on both the ends we have been placed in order to make sure that the surface area is same. That is, whatever that mm square of area is which is available will be the same thing. That is been illustrated with this figure, so that V extension will be is equal to V retraction. V extension will be is equal to V retraction, in which case when we have a double rods on both the end of the piston. Is that clear? When we don't have like this, the double rod, obviously what happens? The size, the surface area available is less. Obviously the pressure exerted on this surface area will also be a different one. Is it clear? So these are the few MCQ questions. Okay. In the next session we will be talking about the rotary type of actuators, and then the cushioning effect.